Assalamu alaikum, welcome back to my channel. We will continue proving questions from the textbook, part 3 from 3D, question number C onwards. The question that we had solved in the last video, it was quite similar to this. So I think you should pause the video and solve. But before that, remember, if you are looking at your textbook, the textbook question is wrong. There's a plus here. If it's a plus, you won't be able to solve it. So change that and we choose the right hand side. Expand the bracket using this identity cos A minus B. So we will get cos A cos B plus sin A sin B. The sign changes here. There's a 2 in the front. Put it before both the terms. You have sin 2b. We can write sin 2b over sin 2b. Using the double angle formula for sin 2b, this one, we will get 2 sin b cos b. Same this side, 2 sin b cos b. Cancel out what you can cancel. This will get cancelled here. 2 will get cancelled and sin b will get cancelled. This will leave us with cos a over sin b plus sin a over cos b. 12d. Tan a over 2 plus cot a over 2 is equal to 2 cosec a. A over 2, most of you might think that let's use the half angle formula. But the half angle formula, I haven't written it down here. If you look, tan a over 2 is not there. It's only sine square a over 2 and cos square a over 2. So what else can we do here? Cosec a is the reciprocal of sine. So we need sine. Before also I have told you that if there's a tan and a cot, and if you want to find a sine or a cos is there in your equation, we use these identities and not the reciprocal one. So in place of tan a over 2, I am going to write sine a over 2 over cos a over 2 plus cot a over 2 will be cos a over 2 sine a over 2. After this step, normally to make the denominator same, we multiply here by cos a2 up and down or sine a2 up and down. Again the same thing, most of you don't understand that, so I will just ask you to cross multiply. Sine a over 2 multiplied by sine a over 2 is sine square a over 2. And let me make myself clear, this is only because most of the students that I come across, they understand like this. This explanation is mathematically wrong, but it works for you also. Sine square a over 2 and cos a over 2 multiplied by cos a over 2 will give us cos square a over 2. In the denominator, we have sine a over 2 and cos a over 2. Whenever you have cos and sine, write sine first and then cos. Now after this step, you have sine square a over 2 plus cos square a over 2, which is equal to 1. If your numbers here are same, a over 2 and a over 2, it could be anything here. It could be 5x and 5x or 10x and 10x. It doesn't make a difference. It's still going to be equal to 1. So now we have 1 over sine a over 2 cos a over 2. You want to change it to cosec. Sine a and cos a, whenever there is a sine a and a cos a, it means that we have to use this identity. What is our a? Our a is a over 2, right? This is how it is. I know we don't have a 2, but So we replace our a with a over 2. This will get cancelled. It will become sine a. The only problem is there is no 2. There is supposed to be a 2 here. When you don't have it, you multiply numerator and denominator both. It's like suppose you got 2 times 3 over maybe 4 times 5. And I put a 6 here, multiply by 6 and multiply by 6. You will still get the same answer. We are just adding up and down something common. This will now give us 1 multiplied by 2 is 2. And I already showed you the down part. This is equal to sine A. 1 over sine is equal to cosec. So now change it to cosec A. We got our right hand side. I know the last one was a little bit tricky, but this one is a good one. Which side will we take? We have the double angle formula here for 10. Because we have cot 2a, we can write the reciprocal of it, right? You know that. So I'll take the right hand side. I will leave the 2 the way it is. In place of cot 2a, I will write this reciprocal. It's going to be 1 minus 10 square theta a over 210a. Multiply the 2 with 1 and with 2 10 square a. The denominator, you can separate it. You have 210a over 210a. This will get cancelled. You are left with 1 over 10a, which can be written as cot a. And this 2 will get cancelled. And there are 2 10. So 110 will get cancelled and you are left with 110a. This is equal to our left hand side. This was quite easy, right? 12F. This is the question and it will be easier to simplify this. That is the reason we are going to choose the left hand side. Just a warning, this is a little bit long question. Not a difficult one, just a little long. The same thing you cross multiply, you will get cos A minus sine A plus 1 multiplied by cos A plus sine A. We will get cos A plus sine A. In the denominator, we can combine it together. We can write cos A plus sine A and cos A minus sine A. The negative sine A and the sine A got cancelled. We are left with 2 cos A. In the denominator, now what do we have? We have cos A plus sine A and cos A minus sine A. It's like that you have A minus B and A plus B. So now we are using the identity in reverse. It is A square minus B square, which is cos square A minus sine square A. What is that identity? It's our double angle. Cos square A minus sine square A is equal to cos 2A. We reached till here. We won't be able to solve it further unless you look at what you want to find. You want to find tan 2A. It means you need a sine 2A on the top. So that's the reason I'll multiply sine 2A on the top. But remember, you also have to multiply in the denominator. This sine 2A over cos 2A will give us tan 2A, what we need. What are we left with now? Sorry for the equal. We are left with 2 cos A over sine 2A. Sine 2A, we'll use the double angle formula and expand it. Many of you might think Now, how am I supposed to know that? By practice and by making notes, that if you need something and it's not available, you can multiply on the top and down. Okay, and proceed further. We are going to cancel the 2. The cos A is going to be cancelled. We'll be left with 1 over sine A, which is equal to cosec A. That's our answer. 12G, we have sine A over 1 plus cos A, and we want to find tan A over 2. If I explain it separately, you might find it difficult to understand. So I will give you a suggestion. Why don't you memorize that whenever you know that sine 2A is equal to 2 sine A over cos A. So if you have sine A, that is equal to 2 sine A over 2 cos A over 2. Because we replaced our A with A over 2. Here we replaced with A over 2 and the 2 gets cancelled. That's how we got sine A. So memorize this. The same thing applies to all the cos rules also. All of them. If I have cos square A over 2 minus sine square A over 2, it will equal to cos A. The same here, 2 cos square A over 2 minus 1 will equal to cos A, and cos A will equal to 1 minus 2 sine square A over 2. I hope that part is clear. The other part we need to know is we want to find tan A over 2. So it means we need sine A over 2 on the top and cos in the denominator. Now keeping all this in mind, we'll choose the left hand side. Remember, sine A is equal to what? It is equal to 2 sine A over 2 cos A over 2. And cos A, I'm going to use this identity. And we have replaced our A with A over 2. That's why we can write it as 2 cos square A over 2 minus 1. This whole thing is equal to this. The 1 minus 1 is cancelled. Now what do we have? We have 2 sine A over 2 cos A over 2 over 2 cos square A over 2. The 2 got cancelled and 1, this cos A over 2 will cancel and 1 from the denominator, leaving us with sine A over 2 over cos A over 2, which in turn is equal to tan A over 2. Okay, so this is equal to our right hand side. Remember, I'm available for any questions. You can message me. We will skip 12H also, that has come in the exam, but not for finding your proving. It was another question, a very simple question. So we'll leave that. We are going to choose the left hand side as tan x is too simple. But we cannot use the double angle formula and all. It will make it very complicated. So first let's change cosec to our basic identity, which is 1 over sine 2x, and see what we get. Cot, because there's a sine involved, we can change it to cos 2x over sine 2x. As the denominators are same, we can join together. Now you have to keep in mind, what do you want to find? Tan x. It means you want sine on the top and cos down. That's the reason we are going to choose from the cos double angle identity the one which has a sign. Remember to put a bracket, and the sine 2x we are going to use the double angle 2 sine x cos x. Expand the bracket carefully. 1 minus 1 plus 2 sine square x. The whole thing is over 2 sine x cos x. 1 minus 1 will be cancelled, and we will also be able to cancel the 2. I can do more cancellation here, but just one extra step. What do you see that can be cancelled now? 1 sine x from the top and the down one will be cancelled, leaving us with sine x over cos x, which is equal to 10x. Question number 12K. J I'm skipping because it is very similar to the previous one which we did, so I'm starting with here. We have 10x is equal to square root of this equation. This is too simple to solve, so obviously we have to use the right hand side. When you are solving for 10x, you need to remember you need a sign on the top and a cos down. Okay, that you need to keep in mind. Now the right hand side, because I need a sign on the top, I will use the double angle for cos 2x, which has a sign which is 1 minus 2 sine square x. And in the denominator, I want a cos. So I will use the one which has a cos. 2 cos square a minus 1. Expand the bracket. 1 minus 1 plus 2 sine square x over the root is for the whole thing. 1 plus 2 cos square x minus 1. 1 minus 1 is cancelled. 1 minus 1 is cancelled. Even the 2 got cancelled. So we now have sine square x over cos square x. As everyone knows, root and the square root gets cancelled. Root and the square gets cancelled, leaving us with sine x over cos x, what we needed to change to 10x. And we proved that it is equal. Moving on to 12L, there are two identities involved here. One is the double angle for sine, and the other is the Pythagorean formula for 1 plus 10 square. It will be difficult to change because it's a simple thing, 2 sine a cos a into this form. That's the reason we use the right hand side. I hope you choose correctly. You're understanding what to do. In place of 1 plus 10 square, we are going to write sec square x. Now how to move forward? Remember that sine 2x requires 2 sine a and cos a. You need a sine on the top and cos down. Also, if we have a over b, I can write it a multiplied by 1 over b. So I'm going to write it as 2 10x multiplied by 1 over sec square x. 10x is going to be sine x over cos x, and 1 over sec square is the reciprocal of cos. We will write it as cos square x. The cos x in the denominator and 1 on the top gets cancelled, leaving us with 2 sine x cos x, which is a double angle formula, what we are looking for, sine 2x. And we proved it, that is equal to the left hand side. Let's solve the next one. We have been given the double angle cos 2x is equal to 1 minus 10 square x and 1 plus 10 square x. For the double angle, we can change it into any one of it and it will be fine. But from the double angle, if I have to change it to this form, it's going to be difficult. So that's the reason, again, I'm choosing my right-hand side. 1 minus 10 square x. I'm using the Pythagorean triplet, this identity. In place, I can arrange it and I can write sec square a minus 1 is equal to 10 square a. So in place of 10 square, I'm replacing sec square x minus 1. And in the denominator, it will be the same. 1 plus 10 square a is equal to sec square x. So I don't need to write the 1 plus here. It's going to be sec square x. When you expand the bracket, you will get 1 minus sec square x plus 1 over sec square x. Did you understand what happened here? In place of 10 square x, I replaced sec square x minus 1. In place of 1 plus 10 square x, I replaced sec square a. 1 plus 1 is 2 minus sec square x. The denominator is for both the numerator, so we separate them. Sec square x can be written as the reciprocal cos square x. Remember, this will get cancelled, which is equal to negative 1. Sec square divided by sec square is 1, which is equal to 2 cos square x minus 1, which in turn is equal to our double angle formula, cos 2x. And we got the answer. Now the last one is remaining. Cos 2x is equal to cos to the power of 4x minus sine to the power of 4x. This is a super easy one. Whenever you have this powers, square or 4, any even powers, we can use the a square minus b square. So the right hand side is equal to cos square x to the power of 2 minus sine square x to the power of 2. Why 2? Because 2 multiplied by 2 is 4. This is like my a square minus b square. So we are going to write this as cos square x minus sine square x, a minus b, cos square x plus sine square x, a plus b. Cos square x minus sine square x is equal to cos 2a. So cos 2x, cos square x plus sine square x is equal to 1. So we don't need to write that. We already proved that it equals to our left hand side. And this brings us to the end of this tutorial. I hope I've helped you. Kindly like the video, share it with your friends, leave a comment in the comment section. Inshallah, I will soon put up for the past paper questions also. Thank you for watching.